Hey guys, today let's have some fun. We're looking at an interesting and challenging problem in number theory. It's about finding the distinct remainders when all the primes are divided by 6 and then totaling up these remainders. As you know, there's no formula to find out all the primes. So, how do we find out the remainders of prime numbers when divided by 6? Does it really look possible? Let's just find out. As you know, these are the prime numbers beginning with 2, 3, 5, 7, 11. It goes on to infinity. There's no formula to find out all the prime numbers. But there is something we know. Given a number which is prime, and if it is greater than or equal to 5, all such prime numbers are expressible in the form 6k plus or minus 1, where k is a natural number. That does not mean any number expressible in the form 6k plus or minus 1 is necessarily a prime number. If this were true, then this would be the formula to find out all the primes. But as of now, there is no formula. That's why the reverse is not true, or the converse is not true. I'll give you a few examples to illustrate this point. Look at number 13, which is a prime number. It can be put in the form 6 multiplied by 2 plus 1. It's in that form where k is 2. 13 is a prime number. We have expressed in this format. Now let's look at another number, 25, which is clearly not a prime number. But this number is also expressible in the form 6 multiplied by 4 plus 1. That means this is also expressible in the form. But it's not a prime number. So this is what I meant. Every prime number greater than or equal to 5 is expressible in the form 6k plus or minus 1. But a number expressible in the form is not necessarily a prime number. But the first idea is enough to tackle this problem given in the question. You can check out for yourself other prime numbers and you will see all such prime numbers are either 6k plus 1 or 6k minus 1. There are two different forms, for a prime number to be expressed. Let's look at prime numbers that are expressible in the form 6k plus 1. What will be the remainder of a number in this form when divided by 6? Obviously, that is 1. Because when you take a number like this part is divisible by 6 and 1 is the remainder. So, prime numbers of the form 6k plus 1 will leave remainder 1. Now, look at a prime number expressible in the form 6k minus 1. What would be the remainder of prime numbers expressible in this form? If you take a number like this, say generally this is the way we write remainder of 6k minus 1 when divided by 6. This is actually remainder of 6k when divided by 6 minus remainder of 1 when divided by 6. The first part is obviously 0 because any multiple of 6 when divided by 6, there will be no remainder. And what will be the second part? Remainder of 1 when divided by 6? 1. So finally, we see that minus 1 as the remainder. As you know, remainder is always a positive integer. So if you get minus 1 as the remainder on simplification, how do you find out the correct remainder? To get the correct remainder, whatever remainder you got will be added to the divisor, which is 6 and 5. So 5 is the remainder of a prime number expressible in the form 6k minus 1 and 1 is the remainder of a prime number expressible in the form 6k plus 1. So we can check out any example of a prime number. For example, let me take 97. This is the biggest two-digit prime number. You divide it by 6. What do you have? 6 you write here. We are not bothered about the quotient you are getting. We are targeting the remainder. So 6. Subtract 6 from 9, then 7 you bring down, 37. How many times 6 goes here? 6 times. And that 6 into 6 will be 36. See, 1 is the remainder. Now take another prime number, 47. Let me divide that by 6. What do you have? It goes 7 times. So 42 we write here. Look at this. 5 is the remainder. You can extend this to any prime number, however big it is. When you divide it by 6, either 1 or 5 will be the remainder you get. That's all. So any prime number greater than or equal to 5, you can put it in the form 6 plus or minus 1. There are two other primes, that are below 5, and that doesn't apply to this. And you need to find out individually the remainder you get. So what about the remainder of prime number 2 when divided by 6? This is just 2. For instance, when you divide any number by a bigger number, the small number is the remainder. Similarly, remainder of the next prime, that is 3, when divided by 6, what is the remainder? That is 3. So what do you finally observe? When you take all the primes starting from 2, the remainders are, in the first case 2, that is 2. In the second case 3, the remainder is 3. And for primes greater than or equal to 5, remainders are 5 or 1. No other remainder you will see. These two numbers keep alternating as you go on to higher and higher prime numbers. Put differently, there are only 4 distinct remainders when you divide any prime number by 6. And basically you are just adding these 4 distinct remainders. And that will be 2 plus 3 plus 5 plus 1. And that's equal to 11. So 11 is the final answer for the problem given to you. Or rather, 11 is the sum of the distinct remainders of all the prime numbers when divided by 6. It's as simple as this. Maybe the problem looks a bit challenging to you, but it's quite a simple idea, provided you know one basic point in number theory, that all prime numbers are expressible in the form 6k plus or minus 1 when the prime number is greater than or equal to 5. This is all you need to tackle this problem. See, I am open to all suggestions on how to improve my videos. So if you would like to comment on the style of my presentation, please do that in the comment section. I'll take care of it. And if you like the solution given here, please press the like button and subscribe to my channel. And also don't forget to hit the bell icon so that you will be getting notifications of similar interesting problems. Thanks for watching and see you in the next video.